of houseboat. Houseboat now reads unambiguously only as a kind of boat. It is this property of recursion that allows for projection and labeling of a phrase to take place, in this case, that the noun boat is the head of the compound, and house acting as a kind of specifier, modifier. External merge. First merge establishes substantive base structure of inherent to the VP, yielding theta argument structure of, and may go beyond the lexical category VP to involve the functional category light verb VP. Internal merge. Second merge establishes more formal aspects related to edge properties of scope, and discourse-related material pegged to CP. In a phase-based theory, this twin VP-CP distinction follows the duality of semantics discussed within the minimalist program, and is further developed into a dual distinction regarding a probe-goal relation. As a consequence, at the external first merge-only stage, young children would show an inability to interpret readings from a given ordered pair, since they would only have access to the mental parsing of a non-recursive set. See Roper for a full discussion of recursion in child language acquisition. In addition to word order violations, other more ubiquitous results of a first merge stage would show that children's initial utterances lack the recursive properties of inflectional morphology, yielding a strict non-inflectional stage 1, consistent with an incremental structure-building model of child language. Generative grammar, associated especially with the work of Noam Chomsky, is currently one of the approaches to children's acquisition of syntax. The leading idea is that human biology imposes narrow constraints on the child's hypothesis space during language acquisition. In the principles and parameters framework, which has dominated generative syntax since Chomsky's 1980 lectures on government and binding, the Pisa lectures, the acquisition of syntax resembles ordering from a menu. The human brain comes equipped with a limited set of choices, from which the child selects the correct options by using the parent's speech, in combination with the context. An important argument, which favors the generative approach, is the poverty of the stimulus argument. The child's input, a finite number of sentences encountered by the child, together with information about the context in which they were uttered, is, in principle, compatible with an infinite number of conceivable grammars. Moreover, few, if any, children can rely on corrective feedback from adults when they make a grammatical error, due to the fact that adults generally provide feedback regardless of whether a child's utterance was grammatical or not, and children have no way of discerning if a response was intended to be a correction. Additionally, when children do understand that they are being corrected, they don't always reproduce accurate restatements. Yet, barring situations of medical abnormality or extreme privation, all the children in a given speech community converge on very much the same grammar by the age of about 5 years. An especially dramatic example is provided by children who, for medical reasons, are unable to produce speech and, therefore, can never be corrected for a grammatical error but nonetheless converge on the same grammar as their typically developing peers, according to comprehension-based tests of grammar. Considerations such as those have led Chomsky, Jerry Fodor, Eric Lenberg and others to argue that the types of grammar the child needs to consider must be narrowly constrained by human biology, the nativist position. These innate constraints are sometimes referred to as universal grammar, the human language faculty, or the language instinct. Representation in the brain. Recent advances in functional neuroimaging technology have allowed for a better understanding of how language acquisition is manifested physically in the brain. Language acquisition almost always occurs in children during a period of rapid increase in brain volume. At this point in development, a child has many more neural connections than he or she will have as an adult, allowing for the child to be more able to learn new things than he or she would be as an adult. Sensitive period language acquisition has been studied from the perspective of developmental psychology and neuroscience, which looks at learning to use and understand language parallel to a child's brain development. It has been determined, through empirical research on developmentally normal children, as well as through some extreme cases of language deprivation, that there is a sensitive period of language acquisition in which human infants have the ability to learn any language. Several findings have observed that from birth until the age of 6 months, infants can discriminate the phonetic contrasts of all languages. Researchers believe that this gives infants the ability to acquire the language spoken around Themyscira after such an age. The child is able to perceive only the phonemes specific to the language learned. The reduced phonemic sensitivity enables children to build phonemic categories and recognize stress patterns and sound combinations specific to the language they are acquiring. As Wilder-Penfield noted, before the child begins to speak and to perceive, the uncommitted cortex is a blank slate, on which nothing has been written. In the ensuing years much is written, and the writing is normally never erased. After the age of 10 or 12, the general functional connections have been established and fixed for the speech cortex. According to the sensitive or critical period models, the age at which a child acquires the ability to use language is a predictor of how well he or she is ultimately able to use language. However, there may be an age at which becoming a fluent and natural user of a language is no longer possible. Penfield and Roberts, 1959, capped their sensitive period at 9 years old. Our brains may be automatically wired to learn languages, but the ability does not last into adulthood in the same way that it exists during development. By the onset of puberty, around age 12, language acquisition has typically been solidified and it becomes more difficult to learn a language in the same way a native speaker would. Just like children who speak vocally, deaf children go through the same critical period. Deaf children who acquire their first language later in life show lower performance in complex aspects of grammar. At this point, it is usually a second language that a person is trying to acquire and not a first. Assuming that children are exposed to language during the critical period, it is almost never missed by cognitively normal children. Humans are so well prepared to learn language that it becomes almost impossible not to. Researchers are unable to experimentally test the effects of the sensitive period of development on language acquisition, because it would be unethical to deprive children of language until this period is over. However, case studies on abused, language-deprived children show that they were extremely limited in their language skills, even after instruction. At a very young age, children can already distinguish between different sounds but cannot produce them yet. However, during infancy, children begin to babble. Deaf babies babble in the same order when hearing sounds as non-deaf babies do, thus showing that babbling is not caused by babies simply imitating certain sounds, but is actually a natural part of the process of language development. However, deaf babies do often babble less than non-deaf babies, and they begin to babble later on in infancy, begin babbling at 11 months as compared to 6 months when compared to non-deaf babies. Pre-linguistic language abilities that are crucial for language acquisition have been seen even earlier than infancy. There have been many different studies examining different modes of language acquisition prior to birth. The study of language acquisition in fetuses started back in the late 1980s when different researchers discovered that very young infants could discriminate their native language from other languages. In Meller et al., 1988, infants underwent discrimination tests, and it was shown that infants as young as 4 days old could discriminate utterances in their native language from an unfamiliar language, but could not discriminate between two languages when neither was native to Themyscira. These results suggest there are mechanisms for fetal auditory learning, and other researchers have found further behavioral evidence to support this notion. Fetus auditory learning through environment habituation has been seen in a variety of different modes, such as fetus learning of familiar melodies. Hepper, 1988, Story Fragments, De Casper and Spence, 1986, Recognition of Mother's Voice, Kisileski, 2003, and more evidence of fetus adaptation to native linguistic environments. Moon, Cooper and Pfeiffer, 1993, Prosody is the property of speech that conveys conveys an emotional state of the utterance, as well as intended form of speech, whether it be a question, statement or command. Some researchers in the field of developmental neuroscience would argue that fetal auditory learning mechanisms are solely due to discrimination in prosodic elements. Although this would hold merit in an evolutionary psychology perspective, i.e. recognition of mother's voice, familiar group language from emotionally valent stimuli, some theorists argue that there is more than prosodic recognition in elements of fetal learning. Newer evidence shows that fetuses not only react to the native language differently from non-native, but furthermore that fetuses react differently and can accurately discriminate between native and non-native vowels. Moon, Lagerkrantz, and Cool, 2013. Furthermore, a new study in 2016 showed that newborn infants encode the edges of multisyllabic sequences better than the internal components of the sequence. Ferry et al., 2016. Together, these results suggest that newborn infants have learned important properties of syntactic processing in utero that can be seen in infant knowledge of native language vowels and the sequencing of heard multisyllabic phrases. This ability to sequence specific vowels gives newborn infants some